So this R9 that I picked up gets hot as hell. But that's alright. I bought this because I wanted the reference cooler. Oh, by the way, if you want to see that video when I put this in the computer and take some temperatures, I'll put a link somewhere. But I wanted the reference cooler because I want to water cool this with one of those 120mm all-in-one coolers that I have. So the plan is to completely disassemble this, cut a hole in the shroud up here, replace the inside heatsink with the water block and the pump, and then run the pipes out here onto the radiator and then put everything back together. I want to keep the heat plate and the bottom and the fan in place and keep it as stock looking as possible. So that's going to be a little project that we'll do today and see how that works out after everything's said and done. So it shouldn't be too hard to take apart. And you just got the screws in the back holding the shroud and heatsink in place. And the 4 screws holding the core in place, or the heatsink over the core. Should be alright with just a Phillips screwdriver. Let's see which one will fit. It's a sapphire card, so I don't have the stupid stickers on here that say warranty void if seal is broken or if removed. So let's get to work. Let's get to twerk. Yeah, it's a used card. You can see all the dust on it from the person that bought it. That's fine with me. It's just something to play around with. You can see it's got little seals on it. So those are the 4 screws for the what hold the heatsink on the GPU. Now, you ready? There are 2 screws right in there. I'm gonna have to take out as well. And they're quite a pain in the ass to take out. Let's see if I can use a bigger bit. Oh yeah, that works better. So that's 1. And then got 2. So let's get the back off. There, so that's all done. And now should be able to pull the heatsink and everything off the card. No? Maybe not. Well, let's pull the shroud off first. I don't even know if a bit small enough. I thought the shroud came off in one piece, but I guess I was wrong. Does this fit? Nope. So I guess I'll take the plastic part off first, and then I'll take the rest off. Alright, so that's 6 on top and 6 on bottom. And now that plastic shroud should come off, just like that. Oh. Actually, there's not as much dust in there as I thought there would be. That's really not bad for a card that got a lot of use. There's not too much dust in here either. I'm alright with that. So that's the fan. I'm going to keep this heat plate in place. I'm going to remove this heat sink and everything here. And I'm going to replace this with a water block. So now, how do I remove this? This is probably just being held on. Yeah, I can see it popping up in the back here. So I think it's just being held on by the thermal tape and everything. I'll work my way around it, just see if I didn't miss any screws. It doesn't look like I did. If I take these off. But those just look like they're stickers. So we'll see here. There we go. That got loose. Just move ahead a little bit. Just push. There we go. It's all done. Just unplug that fan. Everything should be done. There. Naked card. Not too bad. Oh. A couple little adhesives came off. Just gonna put these back on here so I don't lose them. Like I said, I want to reuse this part, just not the big heatsink. There. All done. It's actually really light without the heatsink. And Sapphire did do a decent job of putting thermal paste on there, but you can see there's definitely some spots missing, especially around the edge right here and down there. So it covers the center, but this here is all missing. So this was completely naked, wasn't making contact with anything. All of that. So probably a quarter of the die wasn't making contact. Anyways, I'm gonna I'm gonna tear this apart. I'm gonna take that fan off. Actually, you know what? I'm gonna transfer that thermal compound first. that's all on there now. The only thing left is take the fan off and remove these plastic pieces. So I'll set this aside. I'll get to work on this. After removing the heatsink from the card and transferring everything over and removing the fan, I suspended the heatsink on a baking tray with the back plate touching the sides and the little metal wire mesh. I don't even know what that's from. And the heatsink was hanging freely in the air. Then I turned the oven up to 250 degrees Celsius and I put the baking tray with the heatsink in the oven and I let it sit there for, I think it was 5 or 10 minutes until the solder melted. You can see here underneath of the heatsink that all the solder is melted and that the actual heatsink has become detached from the back plate. After I had removed the heatsink from the back plate, I knew that I needed to make room for the water cooler, the pump and the water block to be able to fit into the back plate and sit on top of the GPU core. So I took the back plate out to the garage, I got on my Dremel, and I cut a big hole in the middle of the card where the GPU is. First I wanted to just cut a nice circular hole and then drill out the corners where the mounting bolts would go for the heatsink, well not the heatsink, for the water block and the pump. But the problem with that was that I kept breaking discs on my Dremel to make the small little round circles. So in the end I decided to just cut a big square hole into the card. It doesn't really make any difference. It actually ended up being quite a bit easier to cut a big square hole because I didn't have to move around any corners, and I think I only broke 1 or 2 Dremel discs while cutting the hole. And it was quite quick too. This whole process, I sped it up quite a bit, but it took about, I'd say, 20 to 30 minutes to cut that hole with the Dremel. That includes sanding it and filing it and taking all the measurements. And you can see in a second here, finally got the rest of the bit out. You can see the big hole in the middle there. After I did that, I took a little sanding tool, or sanding, what do they call it, sanding edge or something, I forgot what they're called for the Dremel, and I went around all the edges of the cuts and I ground them down and I sanded them so they would be nice and round and smooth and not sharp, so they wouldn't cut anything, so it wouldn't cut any bolts or screws or tubing or the water block, and it wouldn't cut my fingers when I reassembled it. And then here you can see me just shaking it, all the metal shavings off the back plate. You can see back plate right there, big hole, and that's what the water block's gonna fit in. Now of course I'm gonna wash that off too, but I think I'm gonna call it here. So this is gonna be part 1, and I'll have part 2 up in a little bit with the final results and temperatures and all that goodness. So this is part 2 of water cooling that R9 290 that I started last time. Last time we disassembled the fan and shroud and heat plate on the card, and we cut a big hole in the center to make room for our water block. We're using the Cooler Master side-on 120M to cool it. So this is the conclusion of that, I guess I'd call it. So after cutting the heat plate to fit, I went back and I started to reassemble everything. Here I'm just wiping off the old thermal paste. This is gooped on here pretty good. I'm going to fast forward a lot of this because it's just a lot of the things that I did in the first video, just in reverse. Like right here, you can see me just reassembling the fan back on the heat plate. There are 3 little screws that hold it in place. I also cleaned off a lot of the dust and debris from dremeling out the center of the heat plate and a lot of the adhesive that was stuck on the card. There you can see the fan is reassembled on the heat plate. That's going to cool the VRMs just like it did before. Now this part was such a pain in the ass right here. It was aligning the fan cable from that blower fan and aligning the heat plate back onto the card. This probably took me a good 5 or 10 minutes to do. That's why I'm fast forwarding it. There's a little bracket right underneath the fan that cable has to slip into in order to sit flush with the card. You can see here I finally got it, or so I thought, and I reassembled, or I screwed a lot of the screws back in to hold the heat plate in place, only to realize that the fan cable was off by a couple of millimeters, so I had to take everything apart and redo the whole thing again, and this is the second try. I cut out that first bit where I had to take everything apart again because it probably took an extra 5 or 10 minutes and I didn't feel I needed to put that in the video. So here I'm just screwing the heat plate and the screws from the back of the card back in. So I'll just fast forward this because this takes quite a little bit. There, now that's all back in place. You can see what it's going to look like. You can see the blower on the back. That's still going to be activated by the card. It's going to cool the VRMs and the heat plate, which is going to cool the RAM and the VRMs. And that's missing the big piece in the middle where the cooler's going to go. Speaking of which, here's the side-on 120M that I'll be using. A really nice thing about this cooler is that the mounting brackets for the CPU mounts almost line up 100% perfectly with the mounting holes in the R9 290 PCB. So you can get some small machine screws. I've got 4 of them right here, and you can thread them through the water block, through the standard mounts, and they'll fit almost perfectly into the PCB holes for the original heatsink on the R9 290. So this is almost a perfect bolt-on for this video card. And you don't have to remove the shim. You can leave the shim in place and the water block will make perfect contact with the GPU. I'm using some Arctic Alumina thermal paste. I'm pretty sure that's what it is. There's really not that much difference in thermal paste in terms of degrees at load. You might see half a degree difference between the most expensive and the least expensive thermal paste. I mean, I usually use Arctic Silver, but I didn't have any left, so I'm using some Arctic Alumina this time. I'm applying a little bit of thermal paste each time that I'm holding down the water block to see how much thermal paste I need. You can see that's not quite enough. The die on the GPU is actually pretty big, and I had to try a few times to get the right amount of thermal paste on there. I wanted to get enough thermal paste to cover the entire die and make good contact with the water block, but not smudge over to the sides too much and cover the resistors or the shim that's on the side of the GPU. So here I'm just trying to see how much thermal paste I need. Again, this is the second try right here. So slip that up. See, I'm just going to use a little bit more here. I put some more in the middle, and then what I noticed is that the middle was getting a lot of thermal paste, so I went and I put a couple dabs. Actually, I put 1 dab in each corner, not a lot, just a little tiny bit, because the thermal paste was covering the center of the GPU die, but not the corners. So this is the 3rd time. This is the final time. I was pretty happy with the spread of thermal paste on this. You can see I'm moving it around a bit to get good contact. And there, if I lift it up, you'll be able to see that it makes pretty good contact, and I've got good spread on the GPU die. So now this part was really tricky. Trying to hold the video card, the water block, and a couple of screws in place and thread everything through. So once I got a couple screws in and they're tight enough, I was able to move on to the next two screws. But here you can see I'm holding the card and the water block with one hand. I'm threading in the nuts on the screws. So every time I thread a nut in, I'm making sure that the GPU block is aligned properly. So I'm just finger tightening them. So I have 3 screws in there. You can see I'm moving the GPU block around a bit. So and here's the 4th one. So I had to use the pliers and the little tool to get this one on, just because it was being a little stubborn. But there, I got it after a little bit. So now that's just finger tightened there. And then I go back and I use the little chuck to tighten the screws and the nuts onto the GPU so the water block sits on there nice and tight. I tighten them in a cross pattern so I wouldn't crush any of the corners of the GPU or get uneven contact. Now they're a little tight right there. You can see it's nice and tight. The GPU block moves around a little tiny bit, so I went back and I tightened them just a little bit more. You really don't want to overdo it. You want to be nice and tight, but not too tight, if that makes sense. So after this final time, you see I'm just turning them a little tiny bit to make them a little extra tight. There, so after this last and final time, you can see I'm pretty happy with that, and that the GPU block is on there nice and tight. I wanted to keep the card looking as stock as possible, so I want to reuse the original R9-290 plastic shroud for the fan. So right here you can see I'm just measuring up because I want to cut a hole in the top of the shroud so I can fit the tubes for the water block through the shroud. You see I'm just eyeing it up. It doesn't have to be exact. I'm just going to use a knife to mark pretty much where I want to make my cuts. So I use the knife to mark the cuts in the top of the card. It's actually lined up pretty well with the Radeon logo on the card. You see I'm just looking at it. I didn't want to make the cut too big because that'd look really bad if you have this huge cut in the middle of your shroud and the 2 tiny little tubes coming out. So I'm trying to keep the cut down, but not too small that restricts how much I can move the tubes. See, I measured out one side, I'm just measuring out the other. I'm scoring the inside of the water, not the water cooler, but I'm scoring the inside of the shroud with my little X-Acto knife that I have here. And then I went out to the garage and got my Dremel out again, and I started cutting. It was really tough to cut the shroud because it was plastic. So what was happening is it cut very quickly, but it also got very hot. So you can see as I'm cutting along the edges of my marks here that the plastic is actually melting and building up quite a bit on the sides of the cuts. So the whole process of cutting the plastic piece out of the shroud took about 5 minutes. It wasn't too tough, but there you can see all the melted plastic that's still stuck around the outside of the cut. So what I did when I went back inside, I got my X-Acto knife, or I guess it's a carpenter's knife. I got the knife out again, and I went along all the edges of the cuts that I made, and I trimmed back all that melted plastic. So once I trimmed away all the melted plastic that was stuck on the shroud from cutting that piece out of the center, I lined it up with the video card and the metal heat plate, and I made sure that everything lined up properly. You can see I'm still having a little bit of trouble in the bottom right corner with that fan cable, but I pretty much solved that by screwing in the top 3 screws and then pressing down and screwing in the bottom 3 screws, and that held everything in place quite nicely. See, it's that stupid fan cable that screwed me up every time I tried to reassemble this thing. There, and that's about it for water cooling the R9 with the Cooler Master side-on 120M. The whole process with the cutting and trimming and dremeling and everything, I think it took me about 5 or 6 hours. You can definitely do it in about 30 minutes if you just remove the shroud, remove the heat plate, and just bolt a little water block onto the GPU and stick a fan to blow cold air onto the VRMs. But I wanted to look pretty much from the factory, and honestly I'm pretty happy with how it looks. So we'll go and get on to the performance, and I can guarantee you that I was blown away by how well this worked. So here's everything mounted in the case. I'm using a Cooler Master HAF XB Evo, I think it's called. It's the cube case with a ton of fans and a ton of room, but you can fit this into any case. It's nice and versatile with the radiator. You can see here when I turn it that there's actually enough room inside this case that I could have mounted the radiator fan inside of the case, but I decided to keep it on the outside just in case I need to make some room for cable management. Speaking of cable management, I wrapped the pump cable around the tubing for the water block and then routed it down into the case. Here you can see there's another look at it. You can see the pump cable and the tubing that go to the radiator. Here's a little noise comparison from before. This is with the stock fan running at 55%, which is about what it would run at if you're doing normal gaming. So I'm just going to shut up. I'm going to let you listen to the noise. And this is what it sounds like while the card is running at 100% with the water cooling on there. I have set the fan on the radiator at 65% in the BIOS, and I've set the card fan at 30%, which is plenty to keep it cool and keep the VRMs cool. And here's a nice little shot of heaven running in the background. I was running it for about an hour, so these are pretty decent temperatures. You can see the GPU is at between 58 and 59 degrees Celsius, and the VRMs are steady at 65 and 60 degrees Celsius. So that's a huge improvement over the 94 degrees that I was getting at stock speeds. So I decided to post some overclock temperatures as well. This is with 1150 on the core, 1500 megahertz on the memory, plus 0.062 volts on the core, and a plus 50 power limit. And as you can see, the core is steady right around 69 degrees Celsius, and the VRMs are right at 80 and 66 degrees Celsius. So that's almost a 30-degree improvement over the stock cooler at stock clocks with these overclocks. So I think if you're considering doing something like this, I mean, definitely do it. You can pick up a water cooler for about 40 or 50 bucks, and it's so worth it. Before I did this, I couldn't even get 1100 megahertz on the core without the card completely shutting down, and the RAM wouldn't go past 1300 megahertz. But after this, I'm able to go over 1200 on the core and 1575 on the RAM, so it's a huge improvement. I mean, definitely do this if you have an extra $40 or $50 to spare.